Okay, hey folks, Mark Locklear here with a screencast on Chapter 8 and data types. So this is really good. This is a really good chapter. A lot of good stuff here. This is more on the sort of administrative side of things, and we haven't covered. We'll cover database design in Chapter 10. So this is sort of a precursor to the database design chapter. And then Chapter 11 too gets into more sort of create table statements, which this is, and which for the homework for the coding exercises, I'm going to be asking you to write a create table statement. So we'll look at that at the end of the screencast. But this lecture will probably be a little bit longer, so settle in. Share this. Okay, there we go. All righty, so how to work with data types. I'm just going to sort of work through these because there's just a lot of good. I mean, lots of times it's sort of straightforward, and I don't have a whole lot to say on each particular topic. But this one is more. I mean, there's a little bit to say just from a very broad perspective. There's a lot to say. There's a lot to say on each one of these. So I'm just going to sort of plow through them. So yeah, I'll just start off with character types, or sort of the big picture, the types overall. These are all of the data types we're going to be talking about here. Characters. So generally, we're talking about characters. We're talking about strings or text. Numeric. So obviously numbers. Date and time, and it can be time or date or both. Binary is in here too. Binary, we're generally talking about being able to store things like images, videos, that type of data. And then they've also got a few notes. We'll talk about enumerators and then JSON too. So let's start off with character types. So character types, generally you can have car. Sometimes folks say char. I say car. You can have a car or varchar types. Car is character. Varchar is variable character. So you're able to specify the length of either the car or varchar types by putting a number, by passing a number in the single argument that you've got with each of these. So the big thing, and I'm going to emphasize these with all these data types, is that it really depends. It's a judgment call. Number one, it's not always sort of cut and dry. And then you all are new to this, so you don't really have a clue at this point. But the more you work with data, the more you'll have a sense about, number one, what data types you should use, and then even beyond that, in the case of having to decide how many characters you want, it really depends on the data that you're going to store. And I mean, the examples they've got here, we're looking, if you're storing a state value, you can always count on that being a 2-character value, right? So in this case, they're using the example of California. It's going to be, you're going to be actually storing 2 characters, the CA, and then the bytes used. Notice they mentioned that here. It's a little bit outside of the scope of the class to get too far in the weeds on the bytes, but just know that you need to be thinking about these things, and in this case, the number of bytes and the total amount of storage based on the data you're going to be working with. And it's just, again, it really just depends, right? If you're writing a small application for your church, let's say, and you're trying to store data, you're probably not talking about a huge amount of data, so you probably don't need to spend a whole lot of time thinking about how many bytes a given field type uses. Probably not a big deal. If you're working for Google or Facebook and you're talking about millions of records, you do need to think about that, because it can really be, if you have to go back after the fact and change data types and modify fields, it can be a ton of work. So those are the sort of things you're thinking about. And then also notice here, with the varchar examples they've got here, where they're storing the entire state name, notice that you've got 20 characters, right? Now we'd need to go back and look. California, probably one of the longer, if not the longest state name out there. So you can rest assured that, okay, if I set it to whatever the maximum length is, then I know I'm not going to run into any issues. Now, of course, the downside here is for I'm trying to think of a short state name. Georgia, Florida, no real short. I'm maybe missing one. Texas, let's say Utah. Okay, I guess Utah. That's 4 characters in length. When you're using something like varchar, whatever the max length is, in this case they've set 20 characters. If you store the text Utah, it's still going to be 20 characters in length. It's just going to be padded at the end. So you're in effect, you're wasting space there. Now again, when we're talking about bytes, especially these days, it's not necessarily a big deal. But when you start thinking about mobile devices, when you think about Internet of Things, where you've got an embedded device, where you're maybe you don't have a full hard drive there, maybe you've got a limited amount of space, the amount of bytes can matter. But again, those are the kinds of things you're thinking about when you're trying to set the lengths for cars and varchars. Okay. All right. Integer types. Int is primarily what we'll deal with in this class, but just know that we've got these other types: big int, medium int, small int, tiny int. So you've got a bunch of different options here. Again, just depends on the data you're using, right? Again, from a standard, from just most standard common numbers, int is probably going to do it. But if I'm working for NOAA and the National Weather Administration, somebody like that, they have when we're talking about weather data, very large data sets, and then some of the processing and some of the math that you're doing with those numbers can be very sophisticated. So you might want to look at things like big int or medium int. If you're, again, if you're pulling in data, solar data from the moon and planets, scientific type data, these are often very large numbers. Again, imagine a scenario with NASA, let's say, where you're pulling in data from a satellite or from a telescope. You may be looking at very large, not only large data sets, but large individual values. So for things like that, you're going to really want to consider using some of these other data types. And again, storage is an issue here too. We looked at bytes. You can see the number of bytes there. So you really want to, the balance you're trying to strike is choosing a data type that is really going to be the most efficient from a data storage standpoint. So again, just to take big int for example, if the largest possible integer you're going to have is maybe 8 or 9 digits long, even big int is probably not a good choice. It'll work, but there's a lot of wasted space there. And again, it depends on the data set too. If you're talking about hundreds of records, not a big deal. If you're talking about millions of data points, those, if you've got 3 or 4 extra or wasted bytes that are not being used for each value you store over 1 million or 5 million or 1 billion record data set, you've got a lot of wasted data there. So that's the kind of thing, those are sort of the kind of things you want to think about. Yeah. Fixed point and floating type. So generally when we're talking about financial data, often double, floats, decimal places, those are often things that we're thinking about with financial, although it can span over into the scientific realm too. So you can see the very large numbers here. They've got examples using scientific notation here. Again, very large numbers here. Often the negative numbers you may not need, and again, that this is a balance you're trying to strike. You may only need positive numbers, in which case other data types might work better as opposed to using sort of standard doubles and floats. So those are all the things you're sort of trying to consider here. And then they've got some examples of each one of those. All right, date and time. I always like to say that dates are always near and dear to web developers' hearts. It can be, it's a very important aspect of programming and keeping track of data. When we look at creation dates, when something occurs, it's just, it's very valuable and you have to pay attention to it. Most of the time, modern frameworks and programming languages will take care of a lot of the issues around dates and date times for you, but they don't, more times than not, there are times when you're going to have to come up and need to touch that, whether you're pulling data from a database to display it in a certain format, or whether lots of times when you look at situations where you're trying to import large data sets into a database, most of the time you're probably not going to get lucky enough. So the date or time format is in the exact format you're going to need for the database you're trying to store it in. So often there's a conversion. That has to happen there too. And the other thing, the book talks about this a little, is you have full, with regard to dates, you can store dates as strings, or you can actually store them as a date type. So again, I won't go into all of the nuances as to when you would choose one over the other. There, you've got more flexibility with a string type because there's no date checking that goes on, as opposed to date, time, or time stamp and year. The examples they've got here, there is some validation that happens, so that if you try and insert a date that's in a particular format that doesn't match what the particular data type is, then the database is going to throw an error. So again, it really just depends on it depends on the data you're working with, the system you're working with, and what the requirements are. And lots of times it's up to you to make that decision. And you just sometimes just have to make the best decision you can based on the information you've got at the time. You can always go back and change that, but it can be a lot of work to go back after the fact, especially when data has been stored in a particular format. You often have to export all that data, make your change, and then re-import it in, which is just a lot of work and can cause many issues. So those are sort of things to think about. And again, just some examples here of dates. I mean, you can see sort of the different date types, or the sort of different formats over on the left side. All of these are stored in the same way inside the database, but again, those are things you want to think about. Often this date time, I mean, I'll just say generally from a web development standpoint, often in web apps, the date time data type is often what's used, and it's just sort of, I mean, it's nice because obviously you've got the data and you've got the time there. Now, you may not think time is important, but again, when you have hundreds, thousands, or even millions of transactions going on at one time, you often want a time stamp there that's associated with it too. So often date time is what you see most often. All right, this enumerators was an interesting one, and I'll be honest, before teaching this class, I didn't know, or if I did know, I had forgotten it, that MySQL can handle enumerators. You'll often hear this called either enums or enums. Enums is normally what I say, and enums, I teach this in I think both my Java and C++ classes, if you've had those. So hopefully if you've had those classes, this is not the first time you're hearing this. But enumerators are often a way to sort of control what the input is, right? I mean, they can be text or numbers, but rather than taking any kind of input, it's normally a way to be very structured about the input you can take for a particular field. So in this case, the example they use here is, you can imagine a scenario where you're choosing toppings. Maybe you've got an application for a pizza, for a pizzeria, that someone is choosing toppings. Rather than allowing people to just type in whatever they want, number one, from a data validation standpoint, you're really able to control the exact, number one, the exact spelling, the capitalization. You're able to control all those things. You're not just taking input from people. And you can imagine a scenario on a website where you've got a drop down box and maybe you're choosing the toppings that you want. So And you can do this at the application level, but being able to do this at the database level is just sort of another way to really validate and ensure that the data that's being stored is exactly what you want. The other interesting part of this is the binary value that's stored here. Again, outside the scope of this class, so I won't go too deep in the weeds here, but just know that this is a very efficient and very fast way to store and retrieve data for objects like this. So in this case, they're sort of keeping it simple with pepperoni, mushrooms, and olives. But when we look at the toppings list, if you go to Domino's or Pizza Hut's website and you order online, you'll know that you've probably got maybe a dozen different choices for toppings that you can have. And if you imagine, from just purely from a data standpoint, how you would store that, an array would be one way to do it. But think about the amount of text you've got. Let's say you've got 12 different toppings there, and let's say someone chooses all 12. The amount, just purely the amount of data that's going to be stored is large if you're actually storing the text. But just know that this binary version of an enumerator is a super efficient way to store values like this. And if you notice the example here, if someone, I'm looking down on this, in this case, they're using set, but this applies to enums also. If they just choose one topping, see what that looks like. But notice they can choose multiple toppings, and that still fits in is this either 7 or 8? I think that may be 8 characters. You're able to store multiple values, but it still fits in this 8-character binary data set, which, number one, it's small, so that from a space saving standpoint, it takes up less space. And then also from a retrieval standpoint, and again, that's the speed aspect of it, quickly being able to retrieve that data using binary values like this is a very fast way to not only store but also retrieve data like that. And then let's see, do we say anything about the binary data pipe? Yeah, there's a couple other things about binary, or okay, yeah. So when we talk about binary data types, here we're talking about things like images, videos, things like that. We'll say in my experience, and I feel pretty safe in saying this, you can store things like this in a database, or at least in MySQL. Generally, it's not a smart way to do it. Generally, you don't want to store images and video. There's much more efficient ways to do it, number one, and then number two, it also really can slow your database down. So, I mean, generally, this is one where I would just say proceed with caution when you're talking about storing binary values, and especially things like images and videos inside your database. Generally, it's not a good idea, but there are times where it may be applicable. Again, that's a call you'll have to make. And I mean, just if I had to say like when it's a good idea versus not, I'm just imagining a scenario where, let's say you've got a bunch of icons you're trying to save, like these are 100 by 100 pixel values, very small. So probably from an efficiency standpoint, it's probably not going to be probably not going to put a significant load on your database or something like that. But then now imagine a scenario where you've got videos that are an hour long, and you've got 1,000 or dozens or hundreds of thousands of videos like this. Some type of storage device, whether it's YouTube or like an S3 volume on Amazon, that's probably the right way to do something like that versus storing them in a MySQL database. Again, I'm not that's very high level stuff, so I'm not a database administrator like that. That's my full-time job. I do database in the context of web development, but anyway, that's sort of my 2 cents on that. But either way, know that you have the ability to store binary data, things like again, audio, video, and images inside MySQL if you choose to do it. Just again, proceed with caution, do your research, and really know what you're doing before you move forward. So something like that. Converting data. So this is always a big deal, whether it's with numbers or dates is the other big one too, is that you're constantly, there's this, there's this sort of gulf between what's stored in the database versus what it looks like on the page, right? Again, to use a timestamp example or a date time object that has full date and a full full timestamp there. Generally, you're going to want to massage that data before it's displayed on the screen. You imagine it being stored in a database versus what you actually see on a web page. We're sort of used to seeing dates in a certain format on a web page, and it's just sort of a standard raw date time object is generally not what you want to put there. So this idea of being able to run conversions, pull data from a database and then display it in a certain way on the screen is often a common task that developers have to do. Keep in mind now, you're not changing it. You're not actually changing anything from a database storage standpoint. That object or the data in that field is going to look the same. It's just when it's extracted and actually displayed is when you might want to make changes to it. So MySQL gives you the ability to do that. Most modern programming language also have a ton of methods that allow you to go in, and again, when data comes out in a certain format, I'm thinking about Python, Ruby, Java, all these, again, modern programming languages have all kinds of built-in methods that allow you to change the format of data to display it any way you'd like. Again, that's purely on the visual side. When you're actually viewing it, you're not actually updating it. You're keeping the same format in the database. It's just being changed when it's displayed on the screen. So they talk about cast here for that, this idea of cast and convert. Cast is generally, and I think the book says this, that cast is sort of generally what you use. I've never, generally from a web development standpoint, I generally do these kinds of conversions on the application side. Ruby is where most of my experience is, Ruby and Ruby on Rails. And, Rails has a ton, well, Ruby and Ruby on Rails has a ton of conversion methods that allow you to change the format of data when it's displayed on the screen. So as a web developer, I would generally do it from the application side, never done it on the database side, but again, you've got the flexibility to do it if it's appropriate. Again, just depends on the situation you're in. I would imagine doing it on the database side is probably faster, maybe, than doing it on the web, on the view side of things. But again, it would just sort of depend on the application. It depends on the architecture. You've got all those things. But again, just know that you do have the ability to do these cast and convert functions inside MySQL. Same with the formatting, same deal there. Again, just ways to sort of change the data the way it's stored. And again, think about a financial application is probably a good example of that. If you looked at the raw data in your bank account, it would look very different than what you see on the web application. When you view it there, everything's going to be in a nice 2 decimal format. It's probably got the $ character in the front. If you looked at the raw data on the back end, it very likely may be to 4 and 5 decimal places, no commas, anything like that. So again, there's a big difference in actual raw data that's in the database on the back end and when you view it in some sort of web application. Okay, and that is all for now. We didn't talk about JSON. I think I might have missed that. Let me pause for a second and see if I missed that. Okay, yeah, I knew I had covered, or I knew I had seen JSON data types. It talks about right there at the end. It talks about JSON as a here MySQL provides storage for JSON data types. JSON is a very common data format that's out there, again, outside the scope of this class to go too far in detail there. But again, know that JSON data objects can be stored inside MySQL also. So again, a lot of flexibility. I mean, probably one of the big takeaways here too to think about is a modern, and again, this is not a MySQL thing. This is sort of all modern databases is that you've got full flexibility with all the various data types. I mean, when you think about all of the data that's out on the web and really anywhere on the internet, it's pretty vast. I mean, generally we just probably think about text and numbers, but when you really dig into it, when you dig into the details of all the different kinds of text, the different length of text that's out there, the vast amount of numbers and the different variations in those things from a numeric data standpoint, all the different things you can do, and then things like images, video, things like that. It's nice to know that modern databases can handle this sort of vast array of data that's out there. Last thing I'll talk about is for this week's assignment, one of the things I'm going to ask you to do is to create a database. In fact, I'll go ahead and drag this down here. So I'm asking you, in fact, I'll just read through it here. Imagine you were tasked with designing a database table to store information for students attending a community college. Your table should include relevant fields to accurately capture student data. Below are specific requirements for each field. So I'm asking you what I'm asking you to submit here is a create table statement. We actually haven't covered technically that yet, but a couple things. You can look forward and sort of review chapter 11 if you want. We're not there yet, but there's create table statements there. And you've actually used create table statements up to this point too. The initial setup files that you ran in the beginning of the class. So I've got, this is the, you'll find this in your DB_setup folder in student download. There's a couple different ones. If you remember correctly, we did this for the AP database and then also the My Guitar Shop exercises. And there are a bunch of create table statements here. So no real mystery around that. You haven't actually created them yet, but you're going to do it for this assignment. And again, if you look at each of these, the structure of these create table statements in each rows are the field name, the field type, and then any other things that are associated with it. So I'm giving you some details here. I am giving you things like int and character, date, and I'm giving you those types, but I'm leaving out, there's a lot that's you still need to figure out here. So things like, okay, if it's a varchar, how many characters? If it's a character, how many bytes? And so I'm leaving that up to you. If you have questions, you can send me an email about that and ask. And then finally, these should be valid statements too. You should be able to use your sandbox database to experiment with these. So run them after you create them, run them and make sure they run, because if you send it to me and it doesn't run or I get a syntax error, then I'm going to take off a significant amount of points. Even if the logic is there and I can see what you're doing is right, I want valid statements that actually run. You can also drop tables too. So if you need to do this multiple times and test it, you should have the ability to drop. You have all the rights on your particular sandbox table, so you can drop and re-add or run the create table statement multiple times if you want to. Okay, that is all for now. As always, if you have questions, let me know.